I have to tell you that as an industry leader, which we expect to be, we know that we can't be limited to what we think ourselves. And we are party to a consortium that is at the cutting edge of biofluidics technology. We're part of MF3, which is a microfluidics consortium, which is essentially a trilogy of 17 universities in the United States with steeped scientists in biofluidics, 12 industry partners, of which we are a founding member of MF3, and the U.S. Department of Defense. The objective is to be working on the most cutting-edge biofluidics dispensing and media resources to accomplish and address all of those world trends that you saw a bit earlier in the presentation. Well, I can't talk to you about all of the things that we're working on out of MF3, but let me just highlight a few in brevity here today. One is the dispensing well plate. And you saw 384 pipettes dispensing into our Nexar and array tape. Well, that delivered a 10-fold increase. We're working on another dispensing technology that will go 60-fold again, potentially, above our current technologies. This dispensing well plate, and you can see on this little slide here that's magnified 100 times, that we would use a reservoir, actuation, and capillary action to essentially push fluidics through a micro channel here, obviously very, very small, and through a port directly into our array tape and other media. And here's an animation that actually shows you how that would work. The pulsing action through the actuator would fill and refill those nozzles every 10 milliseconds, again, delivering the possibility of a 50 to 60-fold increase over our current dispensing technologies. Exciting. But one of the most important things and exciting things that I think that we're working on is something that honestly, and from a transparency standpoint, we're purely playing a supporting role on. Have any of you heard the name George Whitesides? I expected so. George Whitesides is the household name, and he's an icon in the biosciences community. And today he is working on an objective. He wants to leave a legacy of driving disease diagnostic costs down to near zero in third world countries. And I think he's going to get it done. His concept is to use a paper, and potentially a paper and tape-based laminate, to be able to do a multitude of disease diagnostics in one small sample of saliva blood at a near zero cost. But rather than me telling you about George's gig, let's hear from him directly.
What is the cheapest possible stuff that you could make a diagnostic system out of and get useful information, add function? And what we've chosen is paper. There's an example of the same thing on a finger showing you just basically what it looks like. One reason for using paper is that it's everywhere. And what you see in the lower right-hand side there is a sample in which a single sample of blood has been put on the top, and it has gone through and distributed itself into these 16 holes on the bottom in a piece of paper. Each one of those spots then becomes a test for a particular set of markers of disease. It's, I think, as low cost as we're likely to be able to come up and make things.
Again, Douglas Scientific, very privileged to be involved in a body of research like this with Dr. Whitesides. Exciting things happening in our company.